Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री सीबीसीएस फिजिक्स ऑनर्स जीई आ एमएससी फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें postulates of quantum statistical mechanics and the equilibrium average of observables ए विषय रे पढ़िबा सो फर्स्ट देखिबा जदि आमे क्वांटम स्टैटिस्टिकल मेकानिक्स यार बेसिक पोस्टुलेट्स गुडा कोन देखो सबु जदि सिस्टम अछि इन नेचर दे ओबे द क्वांटम मेकानिक्स नाउ इन क्वांटम मेकानिक्स ऑल द ऑब्जर्वेबल जदि आमे नबा ऑब्जर्वेबल गुडा को जे कोनसी गोटे सिस्टम रो then each observable will be associated with a Hermitian operator which operates on a Hilbert space. Okay, now a state of a system will be a vector that is given by psi in the same Hilbert space, and if Q is an eigenvector of the position operator of all the particles in this system, then we can write Q psi, এটা को हमें bracket notation रे लिखिला, which is equivalent to psi Q, which is the wave function of the system in the state psi, right? Now the wave function actually furnishes a complete description of the state. आमे जानिछु quantum mechanics माने आमे बुझिबा moving particle which is associated with a wave and thereafter the concept of wave function. Now at any instant of time this wave function psi of a truly isolated system may be expressed as a linear superposition of a complete orthonormal set of stationary wave function. सपोज या को आमे कहबा स्टेशनरी वेव फंक्शन को phi n ताले आमे psi को लिखि परिबा एज समेशन ओवर n cn phi n, and here cn is nothing but a constant can be taken to be a complex number which is a function of time. Okay, and here the index n stands for a set of quantum numbers. Okay, eta quantum number को सूचौछि which are nothing but the eigenvalues of certain chosen dynamical operators of the system. Now যদি আমি square modulus নিয়ে by c and rho, okay, তাহলে it will be indicating the probability that a measurement performed on the system will find it to have the quantum number that is n. Okay, now in statistical mechanics actually we always deal with the system that interact with the external world, and here we can regard the system plus the external world as a truly isolated system. Okay, that means the wave function psi for this whole system, which is a combination of the system plus the external world, will depend upon both the coordinates of the system under consideration and the coordinates of the external world. याकू तमे सिंपली कहले जेमती आमे थर्मोडायनामिक्स रे पढुथिला गोटे थिला सिस्टम गोटे थिला सराउंडिंग से भलिया कथा. सो एठी जो हमें wave function नेचु phi n, it denotes a complete set of orthonormal stationary wave function आगु हमें देखिला. Now here the function psi still formally given by equation 8.1 ऊपर जो equation देखुथिला, but now cn is to be interpreted as a wave function of the external world, and it depends upon the coordinates of the external world as well as on time. Okay, acha, now suppose we consider an operator o. Okay, what operator neba o corresponding to an observable of the system. Then according to the rule of quantum mechanics, यार जदि हमें average बार करिबा, the average result of a large number of measurements of this observable will be instantaneously, but माने at any instant of time will be given by its expectation value. Okay, so we can write this actually এটি expectation of O এই বলে লিখি হবো, okay, which is equal to here psi O psi divided by psi, okay, তার respective value हमें put করে দিলা, we are getting equation 8.2, and here CM is the scalar product but dot product of the nth and mth wave function of the external world, right, and it is a function of time. Okay, and here the denominator of equation 8.2 being identical with psi, which is independent of time, because the Hamiltonian of the system plus the external world is nothing but Hermitian. That is why it is independent of time. Now when we actually measure an observable in the laboratory coordinate system, then we measure not its instantaneous value, rather we measure its time average. Okay, ଯେମିତି କହିଲି ତାহଲେ ଏବେ expectation value ଯଦି ଆମେ ବାହାର କରିବା ଏଟା ହେଉଛି time average. Thus directly the measurable quantity is not equation 8.2 but the following quantity, which is now ଏବେ ଦେଖ numerator change ହେଇଗଲା, psi o psi ଉପରେ ଏବେ ବାର ଆସିଗଲା, okay, so c and cm ଉପରେ ବି ବାର ଆସିଗଲା, okay, ଏଠି ତଳେ ବି, right, ତାହେଲେ ये जो C and Cm bar is nothing but the mean or average of the scalar product, that is C and Cm, over a time interval that is short time as compared to the resolving time of the measuring apparatus, but it is long as compared to the molecular times. Molecular times कहले कौन बुझिबा हमें, it is the collision times or the periods of the molecular motion, जे कौन सी दुईटा molecule भितरे collision हेबा ପାଇଁ ଯେତିକି ସମୟ ଦରକାର ତା comparison ଏଟା, okay, ତା comparison ରେ ଏଟା longer period, right, so we note here that summation over n cn bar is identical with summation over n cn because the later মানে this one is independent upon time, already ଆମେ ଉପରେ discuss कला. Now the postulates of quantum statistical mechanics are the postulates concerning the coefficient C and Cm bar जोटा में equation 8.3 रे देखिला, when it refers to a macroscopic observable of a macroscopic system in the thermodynamic equilibrium. Okay, and for definiteness we consider a macroscopic system which although not truly isolated, पूरा पूरी isolated है नथिबो, rather it interact so weakly with the external world so that its energy is approximately constant. Suppose एथिरे हमें कहबा number of particles in the system be capital N and the volume capital V, ଆଉ यार energy को कहबा जदि it is lying between E and E plus delta, but delta is a very small value, small as compared to the total energy E, ताले যদি H ହେଇଗଲା Hamiltonian of the system, then for such a system it is convenient but not necessary to choose a standard set of complete orthonormal wave function, that is phi n, such that every phi n will be now the wave function for the n particles which are contained in the volume, that is V, and will be an eigenfunction of the Hamiltonian H, which is having an eigenvalue, that is En, or simply we can write H phi n equal to En phi n. Okay, এটা Schrodinger wave equation বলে আসিগলা. So the postulates of quantum statistical mechanics are now the following. এটি ফার্স্ট ହେଲା postulates of equal a priori probability, মানে এটি আমি যদি average নেউଛୁ Cn bar, then it is equal to 1 when the energy eigenvalue is lying between E and E plus delta, and its value is 0 if it is lying outside this range, okay, otherwise रे. तापरे second ହେଲା postulate of random phases. ଏବେ random phases କହିଲା ମାନେ ଏବେ Cm bar its value is 0 when n is not equal to m. Okay, so as a consequence of these postulates we may effectively regard the wave function of the system as given by जोटा आम linear combination रे लिखिथिला as the summation over n b n phi n where b n square is equal to 1 एटा हमरो जो postulate ऊपर जो देखिला equal a priori probability सेही भलिया आछि equal to 1 when en is lying between e and e plus delta or its value is equal to 0 when the value of en is lying outside this range, that is otherwise. So here the phases of the complex number, that is Pn, are random numbers. Okay, that is why it is the postulates of random phases. So in this case we see that the effect of the external world is taken into account in an average way. Okay, and the observed value of an observable which is associated with the operator जो टाइम starting नहीं थीला is now given as the expectation value will be now this much, right? ताको एबे हमें पुट कर देला. So it should be emphasized for equation 8.7 and 8.8 to be valid, and the system must interact with the external world. Okay, otherwise postulate of random phases will be false. System को निहाती भावरे external world सहित interact କରିବାକୁ पड़िबो, and by randomness of the phases we mean no more or no less than the absence of the interference. Interference आमे जानिछु केतेबेले हुए when there is coherency. Okay, so एठी आमे यदि absence of interference कहबा of the probability amplitudes as expressed by equation 8.9, then we are actually saying for a truly isolated system such as the circumstance may be true at any instant of time but it cannot be true for all times. Okay, सबु जेते टाइम ପାଇଁ एटा ट्रू हेई न पारे. Okay, now एको concept रे जदि बुझिबा, postulate of random phases actually implies that the state of a system in equilibrium may be regarded as an incoherent superposition of eigenstate. Incoherent means interference haboni. Okay, and it is possible to think of the system as one member of an infinite collection of system, each of which is an eigenstate whose wave function is nothing but phi n. And since these systems do not interfere with one another as we have seen in coherent superposition, so it is possible to form a mental picture here of each of the system one at a time, and this mental picture will give you the quantum mechanical generalization of the Gibbsian ensemble. And here ensemble defined by the previous postulate is the micro canonical ensemble. Okay, previous postulate mane postulate of equal a priori probability jota thila. So here the time averaging process through which we averaged out the effect of the external world on the system under consideration may be reformulated in terms of the density matrix. Density matrix use करके भी हमें याको reformulate करी परिबा. Okay, so formula 8.2 जदि याको हमें general formula कहला for the expectation value of any operator O with respect to some arbitrary wave function psi, then it may be trivially rewritten in the form like this. एठी देखो psi O psi पड़ीगला divided by psi psi याको एबे हमें यूज करिबा can be written as trace of RO divided by trace of R. एठी जो लेखिला हमें गोटे quantity R means it is equivalent to the scalar product, that is Cm Cn or equivalent to phi n R phi m. Okay, and the last identity being the definition of the operator R with ONM equal to phi n O phi m. And although here R may be depending upon time, but trace जदि नेबा, trace means तमे जानिचो जे कोनोसी गुटे स्क्वायर मैट्रिक्स रे some of the diagonal elements को हमें trace कहिथाउ. Okay, so the trace of R is independent of time and the density operator is the time average of R, so that हमें density operator को लिखि परिबा as the average of R. Okay, so this is all about the basic postulates of quantum statistical mechanics and the equilibrium average of observables.
Thank you.